few moments time to get the screen. So once you click on get data, next, there are multiple options. One simple option is Spark. If you are having Power BI license, then Databricks will also work. Okay, here it is. If in case you have Power BI license, then Databricks will also work, provided you register that Databricks and Power BI in your Azure account. How to do that? Let me show you now. Important. By default, Spark is open source, right? Azure Databricks is not open source, but Spark is open source. So if it is Spark, we can directly connect. It works. So you provide the complete URL, the same URL talking about this one. Other option, we have Azure Databricks. So in case you would like to authenticate, then one simple step, just wait. I'll take you to home. Here you see Active Directory, right? This one, Active Directory. Go to that Active Directory, home Active Directory. There you need to go to your subscriptions. Just wait. This small shortcut navigation. Go to subscription directory. Here we can access the Active Directory option. Go to subscription default directory. And here you will see something called as resource providers. This one, resource providers. Okay. Go to resource providers. Filter by name Power BI. This one, Power BI, and register. For example, here it is, Power BI dedicated, say register, this one, click on it. Okay. I repeat once again. If it is Spark, no problem. It works, open source. If you are using Azure Databricks, Azure Databricks is one of the components which is already available with your subscription. We can directly create the Databricks resource or service. So your Azure subscription components like Databricks should be establishing connection to other cloud platforms like Power BI. So you need to come to this particular screen, resource providers, and click register. Equal. Opposites. This one. Okay. Now back to our screen. So either Databricks provided, the resource provider is registered. If not Spark, either of them is fine. Click connect. Server name. So here is your server format. Protocol. Next. So server and protocol, then data connectivity mode. Either import or direct query, either of them. Okay. Direct query means data is read live from Databricks file system. Whatever data we load and store in Databricks file system, the data is read live. That is direct query. Import applicable for smaller historical data, wherein the DBFS existing data, of course, the selected tables, we are going to select the required tables in the next screen. Those tables data is automatically imported to Power BI in-memory database. The Power BI desktop, a great tool that has its own database platform. We can write queries on top of it. We call them Power Query, ETL operations. That in-memory database is going to load the DBFS data. Either import or direct query. For live data, we go for direct query and click OK. We can also give batch size. How many rows should be loaded at a time? With 10,000 or just leave it as it is. Click OK. What we are doing now? We are establishing connection to the previously configured Spark cluster outside Azure. See there, I didn't sign into my Power BI account, not required. The Power BI cloud is different. Azure cloud is different. Okay, two different clouds. Right now, we have nothing to do with Power BI cloud. I didn't sign in. Just using it as a regular client. It's a non-cloud. I'm outside Azure cloud and trying to access from my computer. No other additional cloud is involved. And this desktop is a free tool. Here is the website link. Okay, next, back to our screen. So username would be token and password would be whatever token you generate. Say connect. Just click on connect. Let's wait. Remember, files will not be shown. Only tables will be shown. Let's wait for a few moments to take some time to connect. Here it is. Remember, there are two files in the DBFS, right? You remember that? Previously, a few minutes back, I was showing two different files.
Yes, sir.
The CSV, right? CSV files, they are not shown. Only tables will be available. Right now in our example, we have only one table. And here, data is ready to consume, correct format. Remember, there are two different ways to store your data. A regular table data you can store in data lake. Data would be in binary format that requires further transformations. It requires further transformation. Generally, if it is a data coming up from a lake, data lake we call it blob data, binary large object data, we go to transform. Means we need to additionally apply something called Power Query. Convert blob data to usable format. But remember, earlier classes, until day before yesterday, we have something called as Spark, right? Spark will take care of all such conversions. Spark is a programmable alternative for Power Query. Yes, extraction of data. Get data means extract data. Transformations. Those things Spark can perform. And right click, just wanted to show you this one, something called advanced editor. Just want to show you Here it is, Apache Spark.tables. This is a Power Query function to extract Spark cluster data. There is nothing called Apache Spark.files. We have only tables. Files cannot be accessible. And this is the complete Databricks URL. Right, until here, until J1P. This one, J1P, complete URL. And here it is, two options. One means import, two is direct query. Import live data is said, right? Two different modes. Here we go. Import, then first mode. Here 2 means direct query mode. Import, data is imported from Spark DBFS table, selected tables to Power BI in-memory database. Set to the Power BI imported to in-memory database used by Power BI. Just put this way. And data will be refreshed automatically or manually. How to refresh it manually? Let me show you. Back to the screen. Say, assume there are some changes. You would like to refresh the data manually. Then this is the actual screen, right? Remember, get data. Once you click on get data, then more and Spark and provide the credentials. If there is some change to your data in the cluster, then here is the option to refresh. Get latest data by refreshing all visuals. This option. This one. Okay, next. One important thing we need to do, or we need to guide as a data engineer, we need to guide the analyst teams. We need to tell them to detect the data types. Reason, if you remember correctly, last week when we are uploading a table to DBFS, let me show you once again. Last week class, you remember data, create table, and browse. You remember this last week class? Very first example, creating a table from the user interface. You remember this?
Yes.
Others, start your practice. I'll continue. Yeah, click on create table. Here, we didn't talk anything about data type, but still we are able to get the aggregation. Yes, we didn't talk anything about data type. I just said in for schema, auto detect data type. By default, it is string data type. 2018 is string, but still we are able to get aggregations. Right? We got that analytics, report, chart, bar chart, or pie chart, etc. Those kind of reports were generated. Aggregations are created automatically for string data. But it's not the case in the regular analytics platforms like Power BI, Tableau. We cannot derive aggregations from string data. So it is the responsibility of the analyst teams to further prep the data. We call it as data prep, PREP prep, prepare the data for reporting. In Tableau, we have something called Tableau prep tool. In Power BI, we have something else called Power Query tool. And what they need to do, select all columns and detect data types. Detect data types. They are supposed to do. Okay. Then finally, close and apply. If in case they are using free tools, they might have some limitation. If they are using an official cloud account, there are no limitation at all. But this is how we need to work. I repeat once again to make it clear. After data extraction, either import or direct query, either of them, analyst teams or analysts need to detect data types. Otherwise, you don't see aggregations here, right? See, there no